So in this video I'm going to discuss about weight in constraints and how can you use the dist keyword to customize the weight for the given sets of values which you have mentioned inside your constraints. So let's begin. So by default, in a constraint, what you will do, you will just constrain the randomization of any particular variable within a given sets of variables, within a given sets of values or range. So by default, the probability of appearing of any value amongst those given sets of value is equal. So suppose if you have mentioned a constraint, and let's say if you have mentioned something like this, a inside uh, and here you have mentioned any range like a inside 1 1 2 3. So this constraint limits the value that a can get to only three values, and those values are 1 2 and 3. So by default, there is a equal number of probability for any of this value to appear. So they have equal weight. So here, I mean, we can say the probability of A getting 1 is let's say 33.33, and same goes for A getting 2, and same goes for A getting 3. So it's equal. So what if you want to customize? What if you want to customize the weight or the probability? What if you want 1 to appear more time for A when compared to the other values? Those are 2 and 3. So you can do that using the dist keyword. So I will just begin with an example. So first I will create a class and I will call that class weight. So inside this, I will declare two random variables. So first one will be A and the second one will be B. So let's begin with our constraint. I will name it dist because here we are deciding the weight distribution for the sets of values which will be mentioned inside the constraint. And I will name it dist underscore C, which stands for constraint. So first I will write a constraint for A. So just to mention the weight distribution for the values mentioned inside the constraint, you have to use the dist keyword. So you have to write the name of the variable, then followed by dist keyword. And then you just have to use the curly brackets or parentheses. And after that, you have to mention the weight of each values. So suppose I want to constrain the values for A to 1 and to a range of let's say 2 to 6. So inside this range there are 5 possible values. Those are 2, 3, 4, 5 and 6. Since I have mentioned the dist keyword, I have to mention the weight. And there are two ways of mentioning the weights, and each of those ways have their own implications. So first I will go ahead and mention the first way, and that is by writing the colon, and then it is proceeded by the forward slash. And after doing that, you have to mention the weight. So by using the forward slash method, the weight will be divided equally between all values if you are using that for ranges. So let me demonstrate this. So first um, I will just mention any value of weight. So for 1, let's mention 50, And for this range, uh, let's mention uh, 50 as well. So what will happen right here, that I have mentioned the colon and the forward slash. So let's just write a comment to understand it better. So the probability of A getting 1 will be, the probability of A getting 1 will be whatever the weight uh, assigned to that particular value, and it is then divided by the total weight of each values. Since we are using forward slash, uh, here you can see that the weight here is 50, so it will be 50, and here you can see the weight is again 50, so this is the total weight here. So this is going to be the probability of A getting 1 within this constraint, and if you just calculate it, it will be 0.5 or 50%. So among all these possible values, which are 7 values, and I mean the six values, the 5 values are from this range, and one will have a 50% probability of appearing among this value. And as for the remaining values which are mentioned inside the range, let's say probability of A equals to 2 will be equals to uh, so since I have mentioned the weight by using the forward slash method, this weight will be equally divided amongst each elements inside the range. So there are total number of 5 elements. So the probability will be 50 divided by 5, because there are 5 elements, so it will be equally divided for each of the elements, and then it will be divided by the total weight for all the possible values. So the total weight is 50 plus 50 or 100. So if you calculate this, it will come out, or it will equals to 0.1 or 10%. So here, since there is only like only one value is mentioned, the weight associated will only assign to that particular value. And here, since there is a range of value, and I have mentioned the weight using the forward slash style, the weight will be equally divided for each of the values or each of the elements inside that range, which I have shown right here. So this will be same for the remaining values or remaining elements inside this range. So you can say that probability of A getting 2 or A getting 3 or 4, 5, 6 will be 10%. So as per this constraint and the associated weight distribution which I have mentioned right here, uh, the one alone contribute to the 50%, or I mean, there is a half, there is a more likelihood of getting a equals to 1 as compared to a equals to 2 or the other values mentioned inside this range. So this is how uh, this kind of weight works. So I will not delay any further, and I will just go ahead and create a module to test our code. So I will mention a queue, and then I will just mention the handle of the weight class, and inside this I will just assign an object to that handle, and then I will just write an immediate assertion that will just randomize this class. So if assertion fails, we will get an error. Let's just write class weight assertion failed. So let's just go ahead and oh, before that, yeah, I need to after after each randomization, or I would want it to randomize for at least 10 times so that we will get different sets of values. And after each iterations, I will take the received value of the variable a as per the specified constraint, and I will just put it inside that qx. So I will just use the pushback method. And here I will use the handle to reference to the variable a. Okay, and after that repetition loop, I will just display the value of the q using the $display system task. All right, everything is ready, and what this will do, this will just randomize that class for 10 times, and after each randomization I am just obtaining the value of a and putting it inside the qx, and then I'm displaying all the randomized values right here. And as per our weight, one has very high likelihood to appear when compared to the other values mentioned inside the constraint. So let's see whether if it works in that way or not. Okay, let's just compile the code. Okay, there are no errors, so let's just go ahead and run the simulation. So as you can observe right here in the console, since we have assigned a probability of weight of 50, and as per our calculations you can see it that the probability of one appearing is 50%, whereas the other values such as the other values ranging from 2 to 6 uh, has probability of 10% each. So you can see it that one is appearing for most of the times. So first we got 6, and then we got 1, and again 1, and again 1. Then on the next iteration we got 6 and 6, which is random. The probability of 6 appearing is also 10%, like any other values mentioned inside the range. So it is just random, and you can see that 3 appeared, and then again 1 appeared and 1 appeared. So this is the fun part with the weighted distribution. You could enforce your constraint to for a variable to have that particular value for higher number of times as compared to the other values. So the using colon and forward slash is one of the method of assigning weight. So there is another way of doing that thing, and it is a bit different. So allow me to use that different method for the variable b. So let's do it. I will just quit the simulation, and inside this constraint I will do the same thing, and I will just use the same values. That first one will be 1, and second thing will be a range consisting of values from 2 to 6. So this gives us 5 possible values, but this time instead of using colon and forward slash, I will use colon and equals to, and I will assign the same weight. So how does this differ? Let me explain. So I will do the same thing. So for the single values, it is just the same thing. It will just assign a weight of 50 to that value, like this one. But here in this range of value, it plays a different role, because previously the weight which was mentioned inside the range for the range is equally divided for all the elements of the range. But here in this case, it won't be equally divided. Instead, it will be equally assigned. It will be equally assigned to each of the elements. So each of the elements ranging from 2 to 6 will have an equal weight of 50, which is which is quite different, because in this case each elements were getting divided values. So the 2 was getting a weight of 10, the 3 was getting a weight of 10, and so on till 6. But here 2 will be getting a weight of 50 just like 1, and 3 will be getting the weight of 50, and the same goes for 4, 5, and 6. So I will just write a couple of comments. So here uh, it changes the entire game, because the total value that will determine the probability is also changed. So here first let's calculate the probability of A getting 1. So this time it will, so first thing we will do is to write the weight associated to that value, and it is 50, and then it should be divided by the total weight. So with our first constraint, the total weight was 50 plus 50. But here, since 50 is getting replicated for each of the elements mentioned inside the range, the total weight will increase. So there will be 5 copies of 50s because of this range. So first, first will be the weight of the one, and second will be the weight of each elements. And there are total number of 5 elements. So 50 will get multiplied 5 times. So this will be the probability of A equals to 1. And if you just calculate it, you will get 1 by 6, or which roughly converts to 16.66%. So it changed the probability for A equals to 1, because here 50, the weight 50 will be assigned equally to all of the elements mentioned inside this range. So what about the remainder of the values which are mentioned inside the range, that is from 2 is to 6? So uh, for that, let's say A will get 2 or 3 or 4 or 5 or 6. So that will be literally the same in this case, which is the weight associated to each element. So here the weight associated to each element was 10, because the weight was getting divided, because we were using the forward slash, but here we are using equals to. So weight associated to each element is 50, and then it will be divided by the total weight, which is the weight of 1, and then the weight of the remainder of the values. So it will be equals to 16.66%, which is same. So in this case, each of the elements and the possible values mentioned inside the constraint will have an equal probability. So the weight is also equal, which you can see it right here, that one has also a weight of 50, and all the elements inside this range has each of them has a weight of 50. So let's find out whether it turns out to be true or not. So I will just make another queue. Let's name it Y, and I will use that queue to push all the possible values, all the randomized values of P. Then I will do the same thing. Oh, let's save the code and let's compile the code. All right. So let's run the simulation. So you can just observe right here in the console that unlike our previous constraint, which basically has the same sets of values, but the weight was equally divided for each of the range, unlike this one in which the weight was equally assigned to each values in the range. So in the second constraint for the variable b, we were having equal probability for all the possible values. So in the first constraint, you can see that one is appearing more time as compared to the other values. But in the second constraint, you can see that each of them are appearing or have the same probability. So you can see right there that one is not appearing more frequently, which was the case for our previous constraint. So these two were two of the methods of distributing the weight within the constraint, and you just have to use the dist keyword, and you have to use desired um, the desired method you want to use for the range of values as per your operation. So that's all for uh, weight distribution inside constraint. I hope you find this video useful and stay tuned for more. Thank you so much.